Well, my name's Patrick Randall with Hepure. Today we're going to discuss the development of activated carbon PFAS absorption isotherms. The isotherms are key to selecting the best carbon for a given contaminant and estimating the quantity of carbon needed to reach removal goals. I would like to start with an introduction to Hepure and ARQ and a brief discussion of this team. I'll then take a look at what is activated carbon. I found this to be very helpful, and then get into the design for PFAS capture. Hepure has been supplying remediation technologies since 2008 and also provides design services. This is a short list of the technologies we have available, which include zero valent iron, permanganate, hydrogen peroxide, and many more. You can download our product sheet with the QR code at the end of the presentation. ARQ is a public company trading on the NASDAQ and is one of the top manufacturers of activated carbon in the U.S. They serve over 130 municipalities and over 400 industrial sites. They own the coal reserves at the closed mine in Corbin, Kentucky, which supplies their Red River plant in Louisiana. ARQ activated carbon is 100% U.S. sourced and manufactured. Hepure and ARQ have teamed together to ensure a full understanding of the technical needs of remediation clients, backed with activated carbon science and research. Raw coal is obtained from the Corbin, Kentucky mine and is processed to various sizes and goes through carbonization and activation at the Louisiana plant. Contact, conversion, and capture are the key elements in the design of an activated carbon project. Build all three mechanisms into activated carbon design. The amount of surface area correlates to the particle size and provides a surface for deposit of chemical reactants, catalysts, and other chemical functions. The pore opening is an important part of the capture. It must be of a size compatible with the contaminant type. And the particle size must meet the needs of the project and application method, whether injected, placed in barriers, or within filter containers. This picture shows how various surface treatments can be added to assist in efficient capture of the contaminant. Pore size distribution varies by the type of activated carbon, whether coconut, bituminous, or lignite coal. Pore size will determine the capacity and efficiency by which contaminants are absorbed. Coconut has a greater percentage of micropores. Which is good for petroleum hydrocarbons and chlorinated solvents, but comes at an expense of the larger mesopores and macropores for the capture of PFAS compounds. The visual difference between PFOA and typical contaminants show the need to make sure the activated carbon has a proper pore size for the absorption of the contaminant. Due to the small size of benzene and chlorinated solvents, activated coconut works efficiently. But coconut has limited capacity for the larger PFOA compounds. These are the most common types of activated carbon. Wood is used very little. Coconut is the go-to for the remediation industry due to its efficiency of absorbing benzene and chlorinated solvents. Coal-based has an abundance of larger pores, mesopores, and micropores for absorption of PFAS. This shows the typical types and characteristics of activated carbon. Powdered is very fine, usually 12 to 25 microns. Colloidal is less than 3 microns, and granular is generally greater than 25 microns. Now that we have a brief understanding of activated carbon, let's get into how to evaluate different types of carbon with a variety of contaminants. There are a couple of key elements which determine the efficiency by which activated carbon can absorb contaminants. The size of the contaminant molecule is one of these. In addition to size, there are two key elements for maximizing absorption: the charge of the contaminant and the hydrophobicity. Each type of carbon, coconut, coal, wood, etc., have characteristics to take advantage of these key elements. We can build a basic absorption isotherm for each type of carbon and each contaminant. This is done by first preparing activated carbon and PFAS solutions with varying amounts of activated carbon, allowing the mixture to equilibrate, and analysis with liquid chromatography mass spectrometry. The results of the analysis are plotted on a log scale: milligram of contaminant absorbed per gram of carbon by final desired concentration. The curve can be fitted using either a Friedrich or Langmuir isotherm. Friedrich is used due to the abundance of statistical tools available. Based on our desired final concentration in the solution, we can see the amount of contaminant absorbed per gram of activated carbon. With this data by activated carbon type, we can see the difference in capturing the long-chain PFOA molecules. This shows bituminous would require 100 times less activated carbon to reach the equilibrium concentration. Bituminous is capable of capturing 9 milligrams per gram of carbon versus 0.09 milligrams per gram for the coconut. Looking at short chain PFBS, lignite performed better, but all three activated carbons performed fairly well. The difference in carbon absorption becomes very important when dealing with large volumes of water, such as municipal water systems. Here, one ARQ carbon treated over 80,000 bed volumes before 75% breakthrough, compared with 50,000 and 18,000. This would be a significant cost savings in carbon and changeouts. Parameters from the Friedrich curve can be used to develop a model for project design. Client information is entered, and the model will estimate the amount of powdered or colloidal activated carbon needed for the project. This is the results of a pilot test performed on a well to determine how the colloidal carbon would perform under field conditions. Colloidal carbon was injected through a well, and then water was pulled back through the carbon from the well. After initially clearing the pore space, the concentration of all PFAS compounds went below detection limits. Hepure and ARQ are a strong team for design and implementation of activated carbon projects. This includes colloidal, powdered, and granular. We can provide custom-designed activated carbon with higher capacity, faster absorption, higher purity, 100% U.S. source and manufactured. Thank you for watching our presentation. You can scan the QR code to download this presentation and our product list from the Hepure website. Please visit hepure.com to see my contact information and call or email with any questions.